We're going to look at lesson 1.8, which is Introduction to Equations. So on page 53, first word we've got highlighted here is an equation. So an equation is a mathematical sentence that uses an equal sign. Equation uses an equal sign. Almost in the word equation, you see the word equals there. So that's to distinguish that from an expression. In an expression, there is no equal sign. Next thing they talk about in your book is talks about an open sentence. So open sentence we can say open sentence is an equation that contains a variable, and it might be true or false depending on the value of the variable. So anything that has a variable in it could be an open sentence. There will be an exception to that we'll talk about in a minute. So if you look at problem 1, they're asking if these equations are true, false, or open. Part A, there's no variable in it, so it's either true or false. Either it works or it doesn't. So if you add those together, you get 42 on both sides. That's a true statement. That equation is true. Part B, again, no variables. 7 times 8 is 56. 56 is not equal to 54, so that equation would be false. And then part C, there's a variable here, and there's going to only be one value of the variable that'll make this work. So this is open. In other words, it could be true or it could be false, just depending on what the value of the variable is that we put in. So on the got it, they're asking whether these equations are true, false, or open. So on A, we have variables on both sides of this. This is going to end up being open. And kind of what we want to look at is, first of all, nothing can be simplified on either side. And then second, the coefficients of our variables are different. Part B, if we simplify these, we get 9 on both sides. So that equation would be true. And then part C, 32 divided by 8 is 4. 2 times 3 is 6. 4 is not equal to 6. That would be false. A couple more examples that I want to mention that are not in your book here. We could have something like 2x plus 5 equals 1x plus 5 plus 1x. At first glance, we might just say, well, it's got variables in it. It's an open sentence. In this case, though, we actually have some like terms on the right side that we can combine. 1x plus 1x is 2x. And so if you'll notice, both sides of the equation we have 2x plus 5. If we get to a point where both sides, when we simplify, both sides of the equation are the same, this is actually going to be a true equation. If we were solving this equation, if we were solving that, what we would do is subtract 2x on both sides. And if you do that, you get 5 equals 5. So that's a true statement. So this would actually be a true equation, which actually means any value of x that we put in would work. And then a final example here, I guess we could have, let's say we have 2x plus 6 equals, we'll just keep it simple, 2x plus 6 equals 2x plus 5. In this case, if we were solving, if we subtract 2x from both sides of our equation, we would get 6 equals 5. We know 6 is not equal to 5, so that actually is a false equation. And what that means is there's actually no value that we could put in place of the x that would make that equation work. Again, most stuff, if it has variables, again, if you simplify it and you don't have, like this case where the coefficient's the same on both sides of the equation, where the variable would cancel out, Usually those are going to be open, but those are a couple of exceptions I wanted to mention. Look on page 54. Top of the page talks about a solution of an equation. So a solution of equation is a value of the variable that makes the equation true. So when we solve an equation, we are finding the solution. In this case, they're kind of giving us option, like problem 2. Is x equals 6 a solution of the equation 32 equals 2x plus 12? They're not really asking us to solve it. They're just saying, if we substitute a 6 for the x, does that work? So you can see that's what they did. They substituted a 6 in place of the x, and they got 32 on one side, 24 on the other side. Notice the little question mark here because they're checking to see. They don't know if they're equal or not. That's why they put the question mark there. And then you can see those are not equal. So your equal sign with a line through it. Those are not equal. And so then we could say, no, x equals 6 is not a solution of that equation. So same idea if we look at the got it 2. They're asking whether this is a solution. So again, it's basically just substituting in that one value. I mean, you could actually solve the equation and then see if your answer ends up being 1/2 or not, but okay, so once we substitute it in, I really should put a question mark there right away. So with our order of operations, we'll go ahead and take half of 6 here, which is 3. 3 minus 8, if you want to add the opposite on that, you can. That's going to be -5. So the question is -5 equal to 5. And I'm just noticing, thanks to the help of some students here, that I forgot to carry my negative sign down. So the question actually is -5 equal to -5, and the answer would be yes. So is it a solution? We can just say yes. The next part mentions something we've talked about before. In real world problems, the word is can indicate equality. So in other words, is can mean equals. Doesn't have to be, but a lot of times if you see is means equals in a problem. So problem 3, an art student who wants to make a model of the Mayan Great Ball Court in Mexico. The length of the court is 2 4/10 times its width. The length of the student's model is 54 inches. What should the width of the model be? So they kind of picked out some things here. So they said the length is 2.4 times the width. And then they made that into an equation. Before they did that, they define their variable. Probably be better maybe writing it this way. Let W represent the width of the model. And then we're just translating. Length 54 is means equals 2 4/10 times the width. So that translates that to an equation, and then we can solve the equation. So what they're doing in the book is they're saying, oh, it's multiple choice, so I can just try all of these and see if they work or not. So they tried A and it didn't work. They tried B, it didn't work. They tried C and it worked. There's no exponent on the variable, so there's only going to be one answer. So I guess you could do D just to make sure that you didn't mess up, but if one of them works, nothing else is going to work. So we could do it that way. Probably the more efficient method would be that we could say that the variable is being multiplied, so we can divide by 2 4/10. We can divide that out, and when you divide that out, and then you'll get 22 5/10. Okay? Especially if I would have to work this all out by hand, it's probably easier for me just to do one division problem than it is to do 4 multiplication problems. So on the got it, the length of the ball court in La Venta is 14 times the height of its walls. Write an equation that can be used to find the height of a model that has a length of 49 centimeters. And watch the wording here. It technically just says write an equation. We were not asked actually to solve this thing. Okay? So the length is 14 times the height. Okay? You don't have to rewrite that stuff out, but you might find it helpful. So you'd say length equals, remember is equals 14 times the height. And probably again we should define our variables. L is the length, H is the height. And then it says here though the length of 49 centimeters. So if the length is 49, we'll put a 49 in place of L. And then that's my equation. That's all I have to do because it just says write an equation. If we solved it, they're multiplying, so we could divide by 14 and we would get 7.5 or 7.5 centimeters. If we look at problem 4, talks about using mental math to find solutions. Again, I would prefer you guys just work stuff out rather than trying to think it in your head. I know some of these you guys could do, like x plus 8 equals 12, 4 plus 8 equals 12. But again, just in case if we make a mistake, we could say they're adding 8, subtract 8, and then get the answer there. On B, they're dividing, so we could multiply on both sides. Would be 72. 72 divided by 8 equals 9. The nice thing about equations is you can put that answer back in the original equation and see if it works or not. On the got it 3, this would be one case that might be easier to actually use mental math than actually work it out by hand, because this is like a negative y. So just think of it as 12 minus something that equals 3. There's no number in front of the variable, so we can probably get by doing it this way. So we know 12 minus 9 equals 3, so we could say y equals 9. If we were doing that by hand, we would actually have to look, that's a positive 12 out in front. We would have to subtract 12 on both sides, and then we'd have to divide by a negative 1. So we can do it, but I mean, that's pretty straightforward. You guys can probably just come up with that answer there. So we'll look at problem 5. Asks what is the solution of this equation. They want us to use a table. Oh, one more thing before we move on here. The book did talk about using mental math on problem 4. One thing they mentioned though is a limitation about doing that is if a number is not a whole number answer, then it might be hard for you just to think that out in your head. Like if the answer's, 1/8 or 3 1/7 or something like that, depending on what the equation is. Especially if you have numbers in front of the variable and stuff like that, it's going to be maybe hard for you to figure that out, just thinking it out. All right, so anyway, back to problem 5. They want a solution of this equation, and it says use the table. I guess if it says use a table, we need to use a table, so that's what we'll do. What they're doing is just guessing some different numbers here for the left side of the equation and then seeing what that value is. So they tried 5. So 5 times 5 is 25, plus 8 is 33. Okay, we're trying to get to 48, so that's not enough. We try 6. 5 times 6 is 30, plus 8 is 38. Still not enough. They tried 7. Still not enough. They tried 8, and then that worked. So another thing you could notice is that if you increase, since our coefficient is 5, the number in front of the variable is 5, every time you increase by 1, our value is increasing by 5. So you could look at it as 33 we're off by 15, so we're going by 5s. How many 5s until we get 15 more would be 3 more. So we go 3 more, and then we can just get right to that answer. Again, just with practice, you guys might get better at making those kind of observations. And then the book talks about what are limitations of using a table to find solutions. One thing would be, depending if we're not very good at guessing, it could take a long time working all this stuff out till we actually find an answer. The other thing, again, is if the answer doesn't come out evenly, we're going to have to just say, oh, we passed it up. And then we got to go in between these numbers and then, say if my answer is like 3 and 135 thousandths, that's going to be hard for us to just do by a table. So really, realistically, in the long run, for a lot of problems, it's going to be probably a better practice just to actually work them out by hand. But anyway, we can go with this if that's what they want us to do. So the guide at 5, they do talk about using a table here again. One difference on this one is that the variables being subtracted. So we can kind of just copy off of what they did in the book there. This time it's being subtracted. So by increasing our value of the variable, we actually decrease our result in this case. So we're trying to get this to be 55. 55 is our goal. So make sure you write that somewhere or keep that in mind anyway, so you know how you need to adjust. One observation we might say is that we have 25 minus something and we're trying to get to 55. Well, we're starting at 25, we're subtracting. How can we get to a bigger number by doing that? The only way we can do that is if we have a negative value for our variable, because we know right here if you wanted to add the opposite you can, and then a negative times a negative would be a positive, then we would actually end up adding a number basically to that. So we're going to try randomly picking here. We're going to try -5 and see what comes out of that. When you're doing this, you probably want to do your workout to the side. If you want to make this a little bit neater, you can label that number 1 and then make this number 1 off to the side here. So if you do this, we're going to do the multiplication before we do the addition. So -3 times -5. That would be a positive 15. And then if we add these together, 25 plus 15 is 40. Now remember, our goal was 55. So one thing you could say, we're going by 3s here, and we were off by 15. So we could say we need to keep going in that direction. We might be able to just guess it on our next attempt here. If not, just try something else and keep trying until you get it to be 55. So if you followed all of that logic, we could try -10. This is our second attempt here. -3 times -10 would be a positive 30, and then when you add those, you get 55. So that's it. So then the value would be P equals -10. Okay, like I said, if you didn't follow that, we can just keep guessing numbers until we get something that works. And if we look at problem 6, talks about estimating a solution. What is an estimate of the solution? -9x minus 5 equals 28. And once again, it says use a table. So it is asking for an estimate. Usually, if they're saying use an estimate and use a table, probably means it's not going to come out exactly as a whole number or integer answer. So they did the same thing here. They did a table. They tried -1 and they worked that out. and they got 4. We're trying to get 28, so we were at 4 trying to get 28, so we were off by 24. We're going by 9s here, so I don't know that I would just go to the next number if I was thinking about this, but that's okay. They did -2, they got 13, -3, they got 22, -4, they got 31. And so you can see it's going to be somewhere in between here. 24 is closer to 22 than it is to 31. So it's in between -3 and -4. We could say it'd be closer to -3 if we wanted to be more specific. Okay, so same idea with the got it here. So we can make a table here. Remember our goal. Our goal this time is -22. So what you might do just to think about, you've got 3 times a number plus 3, and we want it to be -22. I probably wouldn't guess a positive number. Positive times positive is positive, plus 3 is going to be definitely positive. So I would start in the negative somewhere. So to start out, let's just try -5, see what happens. So -5, we're going to get -15 plus 3, which is -12. Our goal is -22, so we're off by 10 or -10, we could say. So if we want to test this, see if we're going in the right direction here, we could try -6. We want something more negative, so it would make sense picking a more negative number here like we did. So that's -18 plus 3, which is -15. Oh, I forgot to put my value here. So this was -12. This is -15. We're trying to get to -22. So we're going to try -8. We're going to skip over the -7 here. We try -8. So we've got, whoops, make sure you do an 8 there. -24 plus 3 would be -21. We're wanting -22. That is very close. So we have almost reached our goal, not quite, so we'll just go one more step here. If we do -9, that'd be -27 plus 3, which would be -24. And you can see our goal is right in between those two. So this, then we could say our answer would be between -8 and -9. So we'll look at the lesson check. Number 1 is y equals -9, a solution of y plus 1 equals 8. So what we're going to do is just substitute -9 in place of the y. -9 plus 1 is -8. -8 is not equal to 8, so we could say no, that it would not be a solution. Number 2, what is the solution? And it says use mental math. I'm never going to penalize anyone, mark something wrong because you showed your work. If you don't show your work, I might take points off, but like this, saying use mental math, I would rather you guys work it out and get the right answer rather than trying to just think it out in your head and maybe getting the wrong answer. So what we could do, we've done this before, we can say over with the variable, they're subtracting 3, so we can add 3 on both sides. 12 plus 3 is 15, so 15 would be the solution to that equation. Again, you might be able to think about it, you know, a number minus 3 that gets me to 12 would end up being 15. Okay, in your head you might think of, you know, they're subtracting 3, so you might think, well, if I take 12 plus 3, that'll give me the answer. Okay, that's fine, but you know, generally this is what we're going to do on a lot of these problems when we go to solve these things. If you look at number 3, you can read 1.5 pages for every page your friend can read. Write an equation that relates the number of pages P you can read and the number of pages N that your friend can read. Okay. So what we could do is say the pages you can read equals 1.5 times the number of pages your friend can read. And that would be our equation. They're not telling an amount of pages we're reading or the friend's reading, so there's nothing for us to solve. All it said was write an equation for that one. If we look over at number 5, it asks us to write an open equation using one variable and division. So one variable and division, we could do something like x divided by 3 equals 15. Okay, it's an open equation. It only has one solution for that variable. And then number 6 just talks about using different methods to find the solution for that equation and which method you prefer. So they're kind of just talking about, you could potentially use mental math, or you could work this out by hand. So you could say they're adding 4, subtract 4, 13 minus 4 is 9. Okay, and again, that's a little bit up to you at this point. Definitely as we go along, the equations will get more complicated and you'll want to be working them out like this for sure. The nice thing about working it out like this also is that if I do this subtraction, let's say I accidentally subtract that and I say it's 7, I can see that you knew the right approach, you just subtracted wrong, and so you can still get some partial credit versus just writing an answer down and it's wrong and there's no work to go with it, then you're not going to get any credit for that problem. So this gives you an idea of what we're looking at on this introduction to equations.